Voyager 1 is dying in interstellar space, but it changed everything. Welcome to Infinite Science.
More than 15 billion miles from Earth, beyond the planets, beyond the protective bubble of the sun, one machine is still alive.
It was built in the 1970s. It has less computing power than a modern phone. Its cameras have been silent for decades, and every signal it sends now takes almost an entire day to reach Earth.
This is Voyager 1, the farthest human-made object ever sent into space. For nearly 50 years, it has been traveling through darkness, sending messages back to a planet that has changed almost completely since the day it left.
When Voyager 1 launched, there were no smartphones, no social media, no modern internet, and no personal computers like the ones we use today. Many of the people who helped build it are now retired. Some are no longer alive.
But their spacecraft is still out there, still moving, still listening, still whispering back from a place no other human-made machine has ever reached.
But now, Voyager 1 is entering its final chapter. NASA has started shutting down its instruments one by one, not because the mission failed, but because the spacecraft is running out of power. Every watt matters now. Every command is risky. Every signal is precious. And one day, maybe not far from now, Voyager 1 will go silent forever. But before that final silence comes, we need to remember what this tiny spacecraft discovered. Because Voyager 1 did not just explore the solar system. It changed the way humanity sees the universe, and it changed the way humanity sees itself. In 1977, NASA launched two spacecraft toward the outer planets, Voyager 1 and Voyager 2. The timing was extraordinary. The giant planets were arranged in a rare alignment that allowed a spacecraft to use gravity like a cosmic slingshot. By flying close to one planet, the spacecraft could gain speed and be thrown toward the next. This opportunity happens only about once every 176 years. NASA called it the Grand Tour.
Voyager 1 launched on September 5, 1977. Its original mission was simple: fly past Jupiter and Saturn, take measurements, capture images, and send the data back to Earth. Nobody expected it to become an interstellar spacecraft. Nobody expected it to survive for half a century. And nobody expected it to become one of the most important explorers in human history. Its first great destination was Jupiter. Before Voyager 1 arrived, Jupiter was mostly a distant giant seen through telescopes. Scientists knew it had colorful bands. They knew it had the Great Red Spot. They knew it had moons.
But they did not truly understand how violent and complex the Jovian system really was. When Voyager 1 reached Jupiter in 1979, it revealed a world of storms, lightning, powerful radiation, and atmosphere-wide turbulence. Jupiter was not calm. It was a planet of constant motion.
Cloud bands raced in opposite directions. Storms swirled inside storms. The Great Red Spot was revealed as a massive rotating storm, larger than Earth, a centuries-old monster moving through Jupiter's atmosphere like a giant eye. But Jupiter itself was only the beginning. The real shock came from one of its moons, Io. Scientists expected Io to be cold, ancient, and covered in impact craters. Instead, Voyager 1 saw something no one had ever seen before. A volcanic plume rising from the surface of another world. Io was erupting. It was alive with fire. This was the first time active volcanoes had ever been discovered beyond Earth. The discovery stunned scientists. Io was being squeezed and stretched by Jupiter's enormous gravity and by gravitational interactions with nearby moons. That constant flexing generated heat inside Io, melting rock and powering violent volcanoes. Some eruptions blasted material hundreds of kilometers into space. Voyager 1 had revealed that moons were not just dead rocks orbiting planets. They could be active worlds, They could have heat, they could have chemistry, they could be shaped by invisible gravitational forces powerful enough to tear their interiors apart. This discovery changed planetary science forever. Then, Voyager 1 found another surprise. Jupiter had a ring. Not a bright, majestic ring system like Saturn's, but a thin, faint ring made of dust. Until Voyager, Saturn was the famous ringed planet.
But Jupiter had been hiding its own delicate ring system in the darkness. Voyager 1 also discovered small moons near Jupiter, including Thebe and Medes. Suddenly, Jupiter was no longer just a giant planet. It was a miniature solar system.
A world with storms larger than planets. A world with deadly radiation belts. A world with rings. A world with volcanic moons. A world more complex than almost anyone had imagined. After Jupiter, Voyager 1 continued towards Saturn. And in 1980, it reached one of the most beautiful planets in the solar system. Saturn had always fascinated humanity because of its rings. From Earth, those rings looked smooth and elegant. But Voyager 1 revealed something far more complex. Saturn's rings were not simple bands. They were made of countless ringlets, gaps, waves, braids, and strange structures shaped by gravity. Some parts of the rings were influenced by small moons. Other areas looked like ripples spreading through a cosmic ocean of ice and dust. Voyager 1 showed that Saturn's rings were not frozen decorations. They were dynamic, they were active, they were constantly changing under the pull of gravity. The spacecraft also discovered new moons and a new ring around Saturn. But one of the most important targets was Titan. Titan is Saturn's largest moon, and before Voyager 1 arrived, scientists already suspected it had an atmosphere. But Voyager revealed that Titan's atmosphere was thick, hazy, and rich in nitrogen. The haze was so dense that Voyager could not see Titan's surface clearly. Instead of answering every question, Titan created new mysteries. What was hidden below the orange fog? Could complex organic chemistry be happening there? Could Titan preserve clues about the conditions that existed before life began on Earth? Voyager 1 helped transform Titan from a distant moon into one of the most fascinating worlds in the solar system. Later missions would discover lakes and rivers of liquid methane and ethane on its surface, but Voyager 1 opened the door. It showed scientists that Titan was not just another moon. It was a strange, alien world with an atmosphere thicker than Earth's, a world where chemistry could tell us something profound about the origins of life. But Voyager 1's close flyby of Titan came with a consequence. The maneuver sent the spacecraft upward, away from the plane where most of the planets orbit. Voyager 2 continued on to Uranus and Neptune. Voyager 1 took another path. It was heading away from the planets, away from the Sun, toward the edge of interstellar space. But before its cameras were shut down forever, Voyager 1 gave humanity one final image, one of the most important photographs ever taken. On February 14, 1990, Voyager 1 turned around and looked back toward the inner solar system. It was billions of miles away. Earth was no longer a world. It was not a globe filling the camera. It was not the blue planet we recognize from space. It was a tiny speck of light suspended in a beam of sunlight. That image became known as the pale blue dot. Every person who has ever lived was on that dot. Every city, every ocean, every war, every invention, every empire, every dream. Everything humanity has ever known happened on a tiny point of light in a vast cosmic darkness. Voyager 1 did not just show us planets and moons. It showed us perspective. It showed us how small Earth really is, and how rare, and how fragile. Soon after that image, Voyager 1's cameras were turned off. The spacecraft would never take another photograph. But its mission was not over.
In many ways, the most mysterious part of its journey was just beginning. The Sun creates a vast bubble around the solar system called the heliosphere. This bubble is formed by the solar wind, a stream of charged particles flowing outward from the Sun. Inside the heliosphere, the Sun dominates the space environment. Outside it lies interstellar space, the space between stars. For decades, Voyager 1 traveled toward the edge of this bubble. Then, in 2012, it crossed the heliopause. Voyager 1 became the first human-made object to enter interstellar space. It had not escaped the Sun's gravity completely. The solar system extends much farther through distant icy objects and the possible Oort cloud. But Voyager 1 had crossed the boundary where the solar wind gives way to the interstellar medium. For the first time, humanity had a spacecraft directly sampling the environment beyond the Sun's protective influence. And what Voyager found was amazing. Interstellar space was not empty. It had particles, it had magnetic fields, it had cosmic rays, it had waves.
Voyager 1's instruments detected vibrations in the thin gas around it, almost like the spacecraft was hearing the faint hum of interstellar space. A machine built on Earth was listening to the space between stars. That alone makes Voyager 1 one of the greatest scientific missions ever created.
But keeping it alive has become harder every year. Voyager 1 is powered by radioisotope thermoelectric generators. They convert heat from decaying plutonium into electricity. This power source was perfect for a mission traveling far from the Sun, where solar panels would become useless. But the power supply does not last forever. Every year, Voyager produces a little less electricity. And every year, NASA engineers must make harder decisions. They have turned off heaters. They have turned off backup systems. They have shut down instruments. They have reconfigured power systems in ways that were never expected when the spacecraft was built. The goal is simple: keep Voyager 1 alive for as long as possible. In April 2026, NASA shut down Voyager 1's low-energy charged particles instrument to conserve power. That instrument had worked for nearly 5 decades. It helped measure charged particles and cosmic rays. It helped scientists understand the environment around the spacecraft. But Voyager 1 was running low on energy. NASA had to make a choice: turn off one instrument now, or risk losing much more later. That is the reality of Voyager 1's final years. Every system that remains active costs power. Every decision is a trade-off. Every successful signal is a victory. And because Voyager 1 is so far away, communication is extremely slow.
A command from Earth takes many hours to reach the spacecraft. Then NASA must wait many more hours for the response. A single conversation with Voyager 1 can take almost 2 days. There is no joystick, no real-time control, no repair mission, no rescue. Only mathematics, patience, engineering, and hope.
NASA engineers are now working with a spacecraft older than many of the people operating it. Its technology is ancient by modern standards. Its memory is tiny. Its computers are primitive, but somehow it continues to function. That is part of what makes Voyager 1 so extraordinary. It is not powerful. It is not fast by modern computing standards. It is not glamorous anymore. It is a fragile machine flying through cold darkness, surviving on fading power and brilliant engineering. And still, it keeps going. Voyager 1's greatest discoveries were not just scientific. They were emotional. It discovered active volcanoes on Io and proved that alien worlds could be geologically alive. It revealed Jupiter's faint ring and showed that planetary systems are more complex than we imagined. It transformed Saturn's rings from smooth bands into a world of structure, motion, and mystery. It helped reveal Titan as one of the most important moons in the search for prebiotic chemistry. It gave us the pale blue dot, one of the most humbling images in human history.
and it became the first spacecraft to cross into interstellar space. But Voyager 1 also carries something else, a message. Mounted on the spacecraft is the Golden Record. It contains sounds and images from Earth, greetings in many languages, music from different cultures, the sound of waves, the sound of wind, the sound of thunder, the heartbeat of a human being, the song of life on Earth. The Golden Record was not made because scientists expected aliens to find it tomorrow. It was made as a symbol, a cosmic time capsule, a message from one small world to the unknown.
Long after Voyager 1 stops transmitting, the spacecraft will continue moving through space. Silent, frozen, alone. It will drift through the galaxy for millions, maybe billions of years. Its instruments will be dead. Its power will be gone. Its antenna will no longer call home. But the Golden Record will remain, a small piece of Earth traveling through the dark. One day, Voyager 1 will send its final signal. There will be no explosion, no dramatic ending, no final picture, no farewell message. Just one last faint transmission from the edge of the unknown. And then, silence. But that silence will not mean failure. Voyager 1 has already succeeded beyond anything its creators imagined. It explored Jupiter. It explored Saturn. It discovered wonders. It crossed into interstellar space. It carried humanity farther than we had ever gone before. And even now, nearly half a century after launch, it continues to remind us of something powerful. The universe is enormous. Earth is tiny. Human life is brief. But curiosity can cross oceans of darkness. A small machine made by human hands has traveled beyond the planets and into the space between stars. It has survived longer than expected, reached farther than expected, discovered more than expected. And when Voyager 1 finally goes silent, it will not truly be gone. It will still be out there, moving through the galaxy, carrying the memory of Earth, a lonely spacecraft, a golden record, a final message from humanity. And somewhere beyond the sun's fading influence, Voyager 1 is still whispering into the dark. We were here. We looked up, and we reached for the stars. This is infinite science, exploring the mysteries of space, the discoveries that changed history, and the questions that still wait for us in the darkness.